Hello, everyone. In this video series, we're going to talk about an exciting topic that is profoundly transforming the way we manage our facilities: artificial intelligence applied to facility management. Today, I want to delve into how the most recent advances, which occurred between November 2024 and May 2025, are driving our work methodology to new levels of efficiency, sustainability, and economic savings. It's not just about technology. It's about understanding how these innovations impact our daily operations, both technically and financially, and how we can leverage them strategically. We are at a historic moment of paradigm shift, articulated around four major pillars, perfectly reflected in the slide in front of you: artificial intelligence, which acts as the true driver of this transformation; facility management, as a discipline that integrates the management of infrastructure, people, and services; optimization, whose objective is to achieve maximum operational and financial efficiency; and automation, essential for freeing up human resources, reducing errors, and streamlining processes that previously required considerable time and effort. For engineers, this presentation will show concrete examples of how artificial intelligence makes it possible to anticipate failures before they occur, drastically reduce downtime, improve predictive analysis, and intelligently optimize the use of resources. For financial professionals, the goal is to leave you with clear figures and arguments that help you identify potential savings, justify technological investments to management, and calculate the real return on these innovations in your companies. I invite you to begin this journey together to understand why artificial intelligence is revolutionizing facility management and what the paradigm shift we are experiencing means in very practical terms. Today, facility management is abandoning a purely reactive approach and evolving toward a predictive and proactive model powered by artificial intelligence. This shift not only involves adopting new technologies, but also profoundly transforming work culture, processes, and the way spaces and facilities are managed to make them more efficient and sustainable. Until recently, maintenance was only performed when faults or breakdowns arose, forcing improvised work and generating costly interruptions that could affect the operation of entire buildings. Furthermore, many processes were manual, dependent on the individual expertise of technical staff, and based on limited, scattered, or incomplete data. This way of working resulted in inefficient operations, higher accumulated costs, and a very homogeneous user experience, lacking the possibility of customization. Today, thanks to artificial intelligence, we can predict with high precision when and where a failure will occur before it happens, automate routine tasks, monitor systems and equipment in real time, and use resources much more efficiently. This not only reduces operating costs, but also offers more comfortable and personalized environments, tailored to the needs of each type of user. Furthermore, a more proactive level of security is achieved, capable of anticipating risks and avoiding major problems. From an economic perspective, the impact is significant, with a return on investment estimated at between 15% and 30%, depending on the type of installation and the solutions implemented. This advancement has profound strategic implications. It boosts energy efficiency and directly contributes to reducing the carbon footprint, meeting increasingly stringent regulations and corporate sustainability goals. It also allows for optimized maintenance operations, minimizing downtime, and extending the lifespan of assets and infrastructure. Another key aspect is the improvement of the occupant experience, offering more comfortable and adaptable spaces that foster satisfaction and well-being. Furthermore, having real-time data provides a competitive advantage, enabling much more informed, faster, and strategic decisions for building and facility management. Applying artificial intelligence to facility management not only results in savings of up to 30% in operating costs, but also boosts sustainability, increases operational efficiency, minimizes risks, and significantly improves the occupant experience. All of this makes intelligent facility management a strategic tool and a key lever of value for any organization seeking to differentiate itself in an increasingly demanding and competitive market. I want to pose a question: how much money, how many resources, and how many problems could we avoid if, instead of reacting to failures, we were able to anticipate them? With artificial intelligence, these hidden costs and risks are beginning to be significantly reduced, and this is precisely the transformation that is completely redefining the facility management paradigm, preparing it for the challenges and opportunities of the future. Over the past 6 months, we have witnessed breakthrough advances in facility management, with significant technical, economic, and strategic impacts. These developments represent not only technological innovations, but also a profound shift in the way we plan, operate, and maintain buildings and infrastructure. Last November, Sensor Mesh 2.0 was launched. Miniature smart sensors with edge AI capable of analyzing data locally and reducing network traffic by 85%. This not only optimizes data privacy and security, but also streamlines responses to critical situations and significantly reduces operating costs. It is particularly relevant in demanding environments such as hospitals, airports, shopping centers, or buildings with a high density of IoT devices, where the ability to process information in the sensor itself helps avoid network bottlenecks and better manage energy resources. In January of this year, the BIM FM AI standard was published, which establishes how data should be exchanged and structured between digital models and artificial intelligence platforms. This facilitates seamless integration between design, management, and maintenance systems and allows for anticipating problems, planning interventions more accurately, and improving the traceability of each facility component. Thanks to this standard, uncertainty in decision-making is reduced, and the use of resources is optimized at each phase of the asset lifecycle. In March of this year, Predictive FM was launched, the first predictive maintenance platform that achieves over 95% accuracy in predicting HVAC system failures. This represents a qualitative leap forward because it allows intervention before a critical breakdown occurs, avoiding unplanned downtime and financial losses. Furthermore, the platform learns from data in real time, adjusting its algorithms to adapt to the specific usage patterns of each building. This predictive capability not only has an economic impact, but also improves occupant comfort and the sustainability of facilities, as it reduces unnecessary energy consumption. In May of this year, Archgen FM was launched, a generative AI tool focused on space design and planning. This technology can analyze patterns of behavior and space usage to propose more efficient, comfortable, and functional layouts, considering aspects such as people flow, occupancy levels, natural lighting, energy savings, and regulatory compliance. Furthermore, Archgen FM allows users to simulate different scenarios and estimate their economic and functional impact, facilitating strategic decisions regarding renovations, expansions, or space reorganization. This is key for sectors such as offices, hospitals, educational centers, or any environment where space and its use are critical to productivity and well-being. Other notable technological advances include smart sensors capable of measuring multiple variables simultaneously, predictive algorithms that are refined monthly through continuous learning, and generative AI tools that not only create optimized designs, but also produce customized reports and power specialized chatbots. These chatbots, designed to understand the specific facility management context, can resolve technical questions, propose solutions, and support decision-making processes quickly and accurately. For engineers, these technologies mean fewer unexpected breakdowns, more efficient processes, more reliable data, and a preventative rather than reactive approach. For finance managers, they mean significant savings, improved asset utilization, reduced operating costs, and greater financial forecasting certainty. In short, artificial intelligence is consolidating itself as a fundamental pillar for the future of facility management, moving from being a promise to becoming a tool that delivers real and measurable benefits, transforming the way we manage buildings, people, and resources. Technological advances are profoundly transforming facility management, and it is essential to understand how they are applied in practice. Artificial intelligence includes several types, each with specific uses and a major impact on the efficient management of buildings and resources. Machine learning makes it possible to anticipate energy consumption patterns, detect potential failures before they become major problems, and schedule tasks such as maintenance or cleaning based on actual occupancy. This translates into more efficient use of resources, cost savings, and fewer operational disruptions, especially relevant in complex facilities such as hospitals, shopping centers, or corporate buildings. Deep learning goes a step further thanks to the use of deep neural networks that process large volumes of data, images, and sounds. This makes it possible to monitor space occupancy in real time, detect unauthorized access, or identify unusual noises and vibrations that could indicate malfunctions in systems such as motors, pumps, or air conditioning. Thanks to this technology, management goes from being reactive to proactive, anticipating problems before they have an impact. Natural language processing, for its part, facilitates the interaction between people and technological systems. This allows for chatbots that respond immediately to queries or incidents, automatically analyze user comments and opinions to identify areas for improvement, and extract valuable information from technical documents or reports, streamlining administrative work and reducing potential errors. Generative AI is one of the most recent and powerful innovations. It allows you to simulate hypothetical scenarios to predict the impact of changes in space use or energy consumption, create automated and customized reports that easily explain complex data, and design optimized layouts for different building types based on real-world occupancy and behavior data. This technology transforms data into practical solutions tailored to each specific situation. All of this is captured in the image of the smart building, which shows how different AI technologies work together to achieve efficient energy management, predictive maintenance that prevents failures, space optimization, and enhanced security through computer vision and language processing. All of this is captured in the image of the smart building, which shows how different AI technologies work together to achieve efficient energy management, predictive maintenance that prevents failures, space optimization, and enhanced security through computer vision and language processing.